Alright everyone, welcome back to Math 111Z. Today we are going to talk about transformations. So that's section 1.5. Transformations. Okay, so we investigate what happens to a graph if we add or subtract a number from the function, or put x minus a number, x plus a number into the function for x. Like what happens to the original graph. So that's what we're after in this case here. So let's see what happens. So we'll first talk about vertical shifts. And in all these cases we're going to assume that c is bigger than 0. Okay, so vertical shifts. The graph of y equals f of x plus c is the graph of y equals f of x shifted up c units. And then if I do minus, the graph of y equals f of x minus c is the graph of y equals f of x shifted down c units. Okay, so just for the sake of demonstration here, let's do one real quick on Desmos. So if I were to do up here, if I do y equals x squared, I get the basic parabola that we learned in our parent functions. So now if I did y equals x squared plus 2, you're going to see that graph get shifted up 2 units. So see that blue graph is shifted, the red graph shifted up 2 units. And then if I did y equals x squared, say let's do like minus 3, you see that the red graph gets shifted down 3 units. Alright, so that is how it happens if you add or subtract to a function. It has a vertical shift. Alright, let's do another example here. What if I asked you to do this? What is the equation of the graph of y equals x squared shifted, and we'll do down 5 units, and then we'll do up 3 units. Okay, so to go up or down, you're adding or subtracting on the edge of the function. So for this one, we would have y equals x squared minus 5, and that's going to take that parabola and it's going to shift it down 5 units. If I wanted to go up 3 units, I go y equals x squared plus 3 to go up 3 units. Alrighty, let's do horizontal shifts now. So horizontal shifts, you're actually replacing x with like x minus or x plus something. Okay, so we're going to assume c is greater than 0 in this case as well. Alright, so the graph of y equals f of x minus c is the graph of y equals f of x shifted to the right c units. Okay, so it runs counterintuitive. So if you did x minus 2 in parentheses squared, it's going to move that x squared graph to the right 2 units, and we'll show that on Desmos here in a sec. And then the graph of y equals f of x plus c is the graph of y equals f of x shifted to the left c units. And like, hold on, plus should go to the right, minus should go to the left. But just like we did with the circles, remember that x minus h squared thing, y minus k squared thing, the vertex was actually h comma k. So it was the opposite. So let's look at Desmos real quick to see what I'm talking about. So if we go back to Desmos, so instead of doing x squared plus 2, let's do like, we'll put parentheses in front of the x. We'll go x minus 2 squared. And as you can see, that from the red graph to the blue graph, it shifted to the right 2 units. And then say I did with a plus 3 instead, squared. Got to get rid of that. So man, got to get rid of that square there. And there you go. You can see it went to the left 3 units. And that's because if you put negative 3 in for x, right? And negative 3 plus 3 is 0. 0 squared is 0. So that becomes your new x-intercept, or your vertex in that case. Alrighty. So let's do another example. What if I give you this one here? We're going to take we're going to say graph y equals absolute value of x minus 1 plus 2. Alright, so we should look at the parent graph first. So the parent graph here is going to be the absolute value graph. So the parent graph, remember we did those parent graphs a couple sections ago, is y equals absolute value of x. So then if I were to graph absolute value of x, so the absolute value of x is going to be that v centered or vertex to the origin, right? So absolute value of x, we learned in our notes, look like this. So now I'm going to look at absolute value of x minus 1 plus 2. This is a horizontal shift because x has been replaced with x minus 1. That we're actually going to go right 1 unit. And then the plus 2 out here, we're going to go up 2 units. Okay, so if we do that, the vertex at 0, 0 now goes right 1 and up 2. Then every point, right, this 1, 1 would go right 1, up 2. This point at negative 1, 1, right 1, up 2. And we get this new v that is totally shifted to the right 1 and up 2. Okay, so you're going to be faced with some of those on your MyOpenMath assignment. All right, should be able to take care of them. Remember to hit pause if I'm going too fast. You could slow me down. Alrighty, let's do one more example before we turn the page here. Let us do this one. If f of x equals 7 to the x, what equation would result from, and that's what happens when you record a lesson from your home. You get your dog barking at your son that comes through the door. Okay, so if f of x equals 7 to the x, what equation would result from a shift down 8 units. Okay, so up and down, remember, is add or subtract. Like on the end is not going to be up there with the x. It's going to look like this. F of x equals 7 to the x. And the minus 8 is going to totally be separate. It's not going to be up with the x. Now, if I asked you to shift left 5 units, that is going to be up with the x. We're replacing the x with x plus 5, right? To go left 5 units. So remember, left is going to be a plus, so the x up here gets replaced with x plus 5. And if you want, you could put it in parentheses, and that just shows you that you are horizontally shifting, not vertically shifting. Okay, let's talk next about reflecting. All right, we're going to talk about reflecting next. So reflecting is going to be going about the x-axis or y-axis. So let's write this down. Reflecting. The graph of y equals negative f of x is the graph of y equals f of x reflected about the axis. Reflected about the x-axis. Okay, then if I replace the x with a negative x, so the graph of y equals f of negative x is the graph of y equals f of x reflected about the y-axis. Okay? So just for kicks here, let's look at the square root graph and we'll see what happens when we put negative in front of the square root, or we put a negative under the square root with the x. Let's see. So let's try a totally different. We're going to do y equals square root of x. So there's the regular square root graph. Okay, then if I did y equals negative square root of x, you'll see it flips it around the x-axis as promised. And then if I did y equals square root of negative x, you see it flips it around the y-axis. Alrighty, so that's how to reflect around either of the axes. Last thing to talk about in this lesson is stretching or shrinking. Alright, so here we go. We'll talk about stretching and shrinking. Stretching and shrinking. So y equals, I don't like how that n turned out. Look at that, I gotta fix that. That's better. Okay, y equals c times f of x is a vertical stretch if c is bigger than 1 or c is less than negative 1. So if c is less than negative 1, it's going to also reflect. So it's going to stretch and reflect about the x-axis. And then y equals c times f of x is a vertical shrink if c is between 0, or c is between negative 1 and 1, with c not being equal to 0, because if c is equal to 0, then you just have the x-axis, y equals 0. Okay, so once again, if c is between negative 1 and 0, you got a reflection and a shrink. Okay, so here we go. Let's look at Desmos real quick just to show you what's happening. So if we were to go to, if I did say instead of negative radical x, I did like 3 radical x. There's your vertical stretch. Right? Now, if I went down here and I did for some reason it's not letting me. Here we go. So if I did like 1/2 times the square root of x, you'll see there's the red graph, and that represents a vertical shrink from the original. So it squeezed it tighter to the x-axis. All right, and then if I put a negative, say I put a negative 1/2 x, this thing is in my way. I don't know if you can see the Loom video control panel here, but it's stinking things in my way. So negative 1/2 square root of x. You can see it flipped it and shrunk it. Okay, so a lot is going on when you do these. Have your Desmos open when you're doing your homework. It'd be very helpful to investigate what you're looking at. All right, here we go. So let's do another example. How about this one? Describe a function y equals a times f of x plus b plus c if f of x is vertically stretched by a factor of 2, shifted right 3 units. That looks like shifted night 3 units, doesn't it? Okay, we're going to fix that. Shifted right 3 units and down 5 units. Now my open math is going to ask you what's A, what's B, what's C. Alright, so we're going to write y equals, I'm stretching by a factor of 2, so that means that A is going to be 2. I'm going to the right 3 units. To go to the right, it's got to be x minus a number. So it's going to be x minus 3, and then up or down 5 units, so that's going to be minus 5. Okay, so then if we put those in my open math, A is 2, B is going to be negative 3, and C is going to be negative 5. That's what you would answer on my open math. Okay. Last thing, talking about symmetry, and I think we're going to talk about even and odd functions a little bit more later, but here's the definition for even and odd functions. A function is even if f of the opposite of x equals f of x. Alright, so if we looked at a scenario where that's the case, right, so here I have, say that this is x here and this is negative x. This is saying that they have the same y value. So suppose the y value is up here. So f of x is 3, f of negative x is 3. That is going to be an even function, what an even function does, okay? So if I were to draw those, oopsie. If I were to draw these here, you have even functions have y-axis symmetry. Okay, y-axis symmetry. The other one, a function is odd if f of the opposite of x equals the opposite of f of x. Okay, so let's see what in the heck that's talking about here. Alright, so say this is x here, and this is opposite of x. And say that you have f of x equals 1. That means f of the opposite of x is going to be -1. Okay, so an odd function, this could be the example of an odd function right there. So it doesn't have x-axis symmetry, right? No function would have x-axis symmetry. It wouldn't be a function, then it would fail the vertical line test. But it does have a particular kind of symmetry. It's called origin symmetry. Okay, odd functions have origin symmetry. So what that means is it's like a 180-degree rotation. If I took this point and I rotated it 180 degrees, it would be over here. You could also look at it as a double flip. It's like you flip this piece over the x, flip it over the y, and it lies on top, right? That's odd in its origin symmetry. And that's it with section 1.5. Please reach out for any questions, and we'll see you in 1.6.